Hi everyone, in this video I'll be doing Advent of Code 2021, Day 12. I'll be doing the puzzles and then explaining them afterwards. My code is in the GitHub repository, which is linked to down in the description, and without further ado, let's get started on the puzzles. Alright, so today we are still in this cave system and we're trying to find a way out. Basically, we are given a cave system as an adjacency list, so we're given a bunch of edges, and we want to find a way out of this cave system. We have a start and an end cave, and all of these intermediate caves can be classified as either big or small. Our job is to get from the start to the end, passing through all of the caves, but only passing through small caves at most once. So we want to find the total number of paths that go from start to end following these rules. And then they give us a bunch of examples and we need to solve them. So the basic idea is we're going to use a recursive function that searches through all of the caves, starting with the start cave. So when we start with start cave, we're going to start here. And then we're going to search through all of its neighbors. We're going to go look at A, and then we're going to go look at B. When we're looking at A, we can either go to C or we can go to the end. If we go to C, we can go back to A, and from A, we can go to end only, because we can only go through small caves once. And from C to end, from A going to end, that it ends there. Yeah, so after, then going backtracking, after start, instead of going to A, we could go to B instead, and from B, we can only go to end. And yeah, there's a few more. Actually, we can also go back to A, and from there we can go to end. And there's a few more paths here that I haven't explored, but that's the basic gist. We're going to use a recursive function that searches through all of the caves. But there's one catch, which is how we're going to keep track of which small caves we have visited. So I'm going to be keeping track of that using a set. This set is going to contain all the small caves that we visited so far, and we're going to continually update it as we go through the recursive function. So we start here, obviously with starts, and we're going to have this answer variable to keep track of our final answer. First of all, if we are searching the end cave, then we are required to stop here. We can't go back. So we just add 1 to our current count of the number of paths, and then, yeah, that's the end of the function if there. Otherwise, if it's a small cave and we've already visited it, so it's already in our visited set, then we can return as well. Otherwise, if it's a small cave and we haven't visited it yet, then we simply add it to the set of small caves that we have visited. Then we go through all of our neighbors. So for example, if we're at B, then we would add A and D, because we don't want to explore the start cave. And then we just call the recursive function on that new cave. We don't have to handle any of the checking if we're going to another small cave, because when we call the recursive function on that, for example, if we're at D, if we're at B, and we go to D, then when we're searching D, we will recognize that D is invalid through this thing. After that, once we're done searching through all our neighbors and that branch of the tree has finished, then we can remove, we're backtracking here, and we can remove our small cave from the list of visited small caves. If that doesn't quite make sense, take a minute to pause the video and convince yourself that this is true. This is quite a common technique when we're working with depth-first search, is updating variables before and after subtrees have been explored. Alright, now for part 2, we are doing something slightly different. Now we are allowed to visit one small cave twice, and every other small cave still at most once. What I did here was actually make a dictionary or map keeping track of how many small caves we have visited, or actually how many times each small cave has been visited. And this helps because when we're going through our depth first search, our recursion, we can check if a small cave has been visited more than once, and if that has occurred exactly once or more than once. If that has occurred more than once, then obviously we don't want to visit it, but let's just go through the function again. Again, if we're at the end, then we are forced to stop. They actually clarify this in the problem right here. Otherwise, if it's a small cave, then there's a bit of checking we have to do. First, we say, okay, well, this cave is going to be visited once more. Then we have to loop through all the small caves to check if if more than one small cave has been visited twice. So, for example, we're going to say, let's say our path is from start to A to B to D, back to B to A to C. Then we would have visited B twice, D once, and C once, and so far we're looking good. But if we had, for example, visited C twice, which I'm not sure is possible, but say if we had this hypothetically, then we would break here because we cannot visit a small cave. Well, we cannot visit two small caves more than once. We also have to make sure that no small cave is visited more than twice. So if that happens, we also return. Otherwise, at the end, this check, if that is true, then we cannot do this path. And we just want to make sure to reset our cave counting, our visited count, because this cave was not actually searched. So that's our handling for visiting small caves. There's a bit of checking there. After that, we just do the standard stuff, same as part 1. We go through all of our neighbors, add them to the recursive function, DFS, to be checked. And then at the end, again, we remove this cave from the DFS in a similar manner to part 1, except we just decrement the count, which is equivalent. And then we just call the DFS recursive function on the start node, and that just propagates the entire thing. So, yeah. Alright, so that's it for day 12, passage pathing. Hopefully, this video was helpful. I hope you enjoyed it. If you want to see the code, again, that's linked to in the description, and I just want to thank you for watching today's video. I'll see you tomorrow for day 13.